we have got under faculty Mr. Mukund Sharab Hejib. He is C-suite executive in Maharatna company POWERGRID. He heads the Information and Communication Technology Department, and he leads the team which covers not only India but as part of the integrated grid of India, Nepal, Bhutan and Bangladesh as well. I had an intimate relationship with him because he found that I never become a person who can handle IT tool, and he was very correct. I am still not that much comfortable while handling all these equipments. Nevertheless, Mr. Mukund Sharab Hejib is an executive who had been selected in NTPC through All India Selection Test, and he is poised to be at the higher echelons of POWERGRID. I will not take enough of time of either Mr. Hejib or my dear participants from across the globe, US, UK, Thailand, and of course India. So Mr. Hejib will be taking you for a walk as what Industry 4.0 is and how it is getting metamorphosed into Industry 5.0. With this, friends, I hand over the platform to Mr. Mukund Sharab Hejib. Welcome, sir, in World E-University, and the audience are live, active, recording and listening to you. Please go ahead.
Thank you, sir. Thank you. Thank you, Dr. Pandey, sir. It was really a very good introduction. And first of all, I am really thankful to Dr. Pandey as well as the World E-University to give me this opportunity. So already an introduction has been given by Dr. Pandey. I would just like to add a little about my present assignment. I basically look after the IT infrastructure of POWERGRID, be it the user devices or be it the data center, be it networking, or even whatever the core IT services generally you find in large organizations like, for example, email, print and file services, cloud services. So basically, I look after all these in POWERGRID. So now, coming to our topic, I will just share my presentation so that we can start. So whether my presentation is visible, sir?
Yes, sir, very much.
Okay, thank you. So here we start with the basic introduction about Industry 5.0, that is nothing but the fifth industrial revolution. So basically, we right from the first industrial revolution, that is when the human beings understood the potential of applying technology as a means of progress. Steam machinery, assembly lines, and computing. These are some of the basic advancements that have taken place during past few centuries. All of them with the sight on generating technology that will basically improve our efficiency, how we can do more and more production. Most of the technology has been to see that humanity goes further and further, evolves further. But for the probably the war technology, but I really don't know, even nations many times have named that also as a progress, because even the Second World War, Still they say that atomic bomb has proved to the one which has ended the war, so helped humanity in progressing. So we really, the jury is out there. I wouldn't dare to take a stand. Even one funny thing which I remember is in 1876, the Colt company which made the revolver. So even they named it as a peacemaker. I don't know how. So anyway, now coming to our journey to Industry 5.0, let us see the steps what we have covered during all this time, during few centuries. So these are the basically steps. The first industrial revolution, the steam presses, began in 18th century with the use of steam power and mechanization of industrial production. What before produced threads on simple spinning wheels, the mechanized version achieved 8 times the volume of in the same time with the same people. So actually use of steam power was already known, but it was then when it was applied for industrial production, and that's when people, the humans, really realize, okay, how much it can revolutionize the things. And it was further put to use when the steam locomotives were made, and that changed the entire scene, and humans were able to transport humans, manpower, as well as the goods in much larger, in many times, many-fold larger amounts than what they were doing earlier. So, but of course, it took 100 years for the people to graduate from the steam press to the steam locomotives. Then we came to the second industrial revolution, when we saw the electrification of the industrial processes. Henry Ford, he took this idea of mass production using electricity, and he visited a slaughterhouse in Chicago where he saw that pigs were hung and they were moving on a conveyor belt, and different butchers were performing different tasks. Somebody was cutting legs, somebody was taking the slices. So that gave him an idea, and he put these principles in automobile production, and that drastically altered the process. Earlier, the complete automobile was made by a set of people, and now each component was being manufactured. Somebody was only tightening the screw, somebody was only fixing a panel. So that particular person, he became expert in that particular activity. So obviously he was doing it fast. So at the end of the day, it achieved the efficiency and effectiveness. And of course, it lowered the cost. Then we came to the third, that is Industry 3.0, where we saw the use of automation. And of course, the much loved term, that is robots. So actually the term robots, this was first coined in 1920 by some Czech writer, Šapek. It showed about some artificially manufactured roboti which acted like humans, and they performed tasks just whatever their human master told. But as the play shows, that after some time, those roboti, they rebel, and it leads to the extinction of humans. And as you can see that the very term itself has the human fears built into it. The very origin of the robot term has the human fears built in, as we have already seen in the very famous movie series, that is the Terminator. So, but the idea of robot was basically not that. It was basically the robots were first introduced again in the automobile industry to weld car bodies together, and slowly the robots, they traveled, or I will say migrated, from the automobile dull jobs, monotonous jobs requiring again and again same work doing. So we wanted, there was always a desire that, okay, if some mindless machine does it, probably it is better. Same goes about dangerous work, somewhere which is highly corrosive or harmful for humans. Obviously, we would like some machines to go and work there. And so about the dirty jobs. So to eliminate these 3Ds, basically we look towards robot. And of course, there are other requirements like improvement of speed, consistency of quality, and consistency of flow in manufacturing. So then came of late the fourth industrial revolution, that what we call as Industry 4.0, the digitalization. So Industry 4.0 is about the digitalization of the manufacturing environment, which allows for more flexible methods of getting the right information to the right person at the right time. It is based on taking the advantage of the data that industrial machines produce and the use of IT and the real-time data analysis. We also call it as Industrial Internet of Things. Is defined to use intelligent sensors and automation mechanisms to improve the efficiency of industrial processes. So Industry 4.0 can pull individuals into smarter networks with potential of more efficient working, the increasing use of digital devices inside factory, and basically most of the machines are become something like a network node, and those network nodes are able to communicate, or we are able to control them from anywhere. The data is being, because since all those equipment having network connectivity are talking to each other, so we are able to control them from different places. We are able to migrate, take the data from one place to another place, and also the large amount of data that is being generated by these all devices, because most of the equipment, they're having numerous amount of sensors which are providing a lot of data. So all this plethora of data, it has to be analyzed. It has to be meaningful information is drawn out of it. So you also need a data analysis layer. And so once you do that, you are able to have a more informed decision. You are able to provide your workers better information, and he is able to act in a wiser manner. So the increasing use of digital devices inside the factories and out in the field means what? It means that our maintenance people or the working people, they have more information, even manual, which, for example, could be probably available on right on the equipment panel. So solving problem has become much easier with this kind of automation, digitalization of processes. So now we come to the component of Industry 4.0. So I will not say this is an exhaustive list, but these are some of the essential components which form the part of Industry 4.0. The very first thing is Internet of Things, cloud computing, artificial intelligence and machine learning, then edge computing, cyber security, and digital twins. So we see now one by one. Basically, Internet of Things is nothing but a network of sensors which represent some physical quantity of a physical body, physical equipment. So along with a system to process that data, the way sensors are representing the physical objects, the then processing ability, the software, and other technologies. For example, communication technologies that are connecting and which are enabling the exchange of data so that a decision can be taken even by not only by humans, but machine themselves. Because, for example, you want to switch off your refrigerator, you need a data input. Okay, what is the temperature? Now, what is the temperature? That input is coming from a sensor. So now the processor inside the refrigerator or the air conditioner, which is able to take the temperature and able to take a decision. Okay, it's time to switch it off. So that kind of decision is being taken through, basically, because through network that information is available. Even this has a even wider implication. For example, let us say you have a sorry, I think there was a break in communication. Am I audible now? Hello?
Yes, sir, you are audible now.
Okay. So basically, again, Internet of Things, when you see, there is a small thinking in the mind, it's about that all the things or whatever sensors or whatever software, all this should be present on they all should be connected to internet. But no, that's not the case. It's a misnomer. Basically, any system, any network which is able to connect the sensors and the decision making software and other related system would be called as Internet of Things, IoT. Even for that matter, industrial control system is a very good example of an IoT. So, sorry, I think my presentation. So next component we discuss about cloud computing. Now cloud computing is basically, as most of us understand, that it's about something like a, I would, many of my colleagues laugh at this one, but I call it like a Swiggy. So instead of cooking in your own house, you are basically cooking, you are basically ordering cooked meal from somewhere else. So cloud computing is also something like that, where computing resources you are able to take on as a service. So different model of cloud computings are available. For example, infrastructure as a service. For, let us say, a small organization which is not really interested in investing to create a data center and still want to use computing resources, can hire virtual machines or servers, or for that matter, storage. And then whatever cost it would have to invest in the capex, it is able to convert it into opex. So such facility is available through cloud computing. If you go through the basically net, you on Wikipedia, you find basically a definition, the essential component provided by NIST. So it says there are basically 5 elements. First is on-demand self-service, where a consumer can unilaterally provision computing capabilities such as server time or network storage. Let us say he wants higher RAM. He is able to immediately, through a console available to him, request for higher RAM, or suppose the storage the required for the application that is getting filled, he can request or he can requisition higher amount of storage. Then next component, next essential part of the cloud computing is basically broad network access. So it should be available through internet from anywhere. Not that if it is not available across all the platforms, then it's actually a limiting factor. So it allows basically different kind of platforms, or I will say different kind of user machines to access the resources. Then the next component is resource pooling. Because the resources are pooled, same hardware may be running 10 virtual machines or 10 servers. One may be being used by some X organization, another server may be used by Y organization. So basically you are pooling the resources. So obviously you are increasing your efficiency and cost effectiveness. Then of course, rapid elasticity. Because for example, if you take a physical server and the RAM, it is, there is a, let us say you suddenly find that your application is requiring higher RAM and the server resources are not able to meet the requirement. So what do? You will have to go for some another server, or probably if you want to increase the RAM of that server, you will have to switch off the application. You have to shut down the application, you have to shut down the server, then you have to physically insert the RAM module, then again boot, and again boot the application, which may not be always possible, but today's world it is absolutely not possible. If for example, we are running an application called e-office. Now that e-office, I want to switch off that e-application, the hell will break loose in POWERGRID. I can't, suppose there is a sudden heavy rush for that application, I want to increase the RAM, it is just not possible for me in a physical server. But when it comes to virtual server, immediately I can requisition for higher RAM, and that's what we do. In fact, in PowerGrid, we run our own enterprise cloud environment. So we are able to give higher provisioning the RAM, and then immediately seamlessly the application will work. Actually, that's how what we see in when we are using Amazon or Flipkart and all these people, when they go for a sale, their bumper sales and all that time, their demand will be rising manifold. So obviously they cannot provision it beforehand itself, because it is a basically waste of the resources. So it is where this rapid elasticity of the resource provisioning comes into picture. And of course, the last thing is measured service. With just now, whatever example I given. So what they say is ki pay as you go, pay as you use. Now, you don't have to pay for the provisioning. For example, if you take your electricity connection, so if you might have seen that, if you see the bill, there will be some bill for capacity, basically. What kind of load you have taken? So have you taken 8 kilowatt load or 4 kilowatt load or 5 kilowatt? Then there is a usage load that is based on their basically the units consumed. But here it's not like that. Here it is basically you can pay what you use. So how much RAM you have used, so how much compute you have used, how much storage you have used. Accordingly, their payment models are available and you can pay accordingly. So basically, cloud computing is a cornerstone for Industry 4.0. So whatever full realization of smart manufacturing, which demands connectivity and integration of engineering, supply chain, production, sales and distribution, as well as service. So cloud makes it possible because it's basically accessible for different stakeholders, and different stakeholders are putting data there. So it is basically cloud, which is proving to be something like I will dare use the word backbone for basically connected systems. Large amount of data is being stored and analyzed. Again, there are different software. It may become very difficult if we go for a basic hardware-based siloed server system to do this kind of connections and connectivity and integrated operation. It also, as I already told, it reduces the cost for the startup people, small and medium-sized organizations who want to use the IT, in the sense computing resources, without investing heavily on the cost required to set up a data center, then servers, then networking equipment, firewall itself costs, I will say, fortune. Now next, basically AI and machine learning. So AI and machine learning, it allows manufacturing to take a full advantage of the volume, because as we have seen, large amount of information is available through sensors as well as mainly through sensors. So AI can be applied on that to draw conclusion, and even we can come to know, for example, it is possible to predict when a particular equipment is going to fail based on the analysis of the data. And instead of waiting for a breakdown and attending to it, we are able to predict when that breakdown is going to take place, and then you can take a preventive outage. And because a preventive outage is certainly much economic and orderly than a breakdown maintenance. Now, coming to the next component, that is edge computing. Now, edge computing is something which is, I will say, a slightly antithesis. I will not, is slightly apparently contradicting to what cloud computing is about. Edge computing is about analyzing the data where the data is. Now, again, let us not think that if I have a cloud computing, then why I have to go on retro and go back to the again doing analysis where the data is there. Please understand that once we talk of cloud computing, basically we are talking something about the resources on internet. And for any organization, the connectivity to the internet is through a basically metered internet links. You have firewalls, you have internet links, and if the usage is heavy, there is always a chance that your internet link may choke and you may not get the service as fast or as efficient as you are expecting. That may be all right for many this one that you may wait, but for critical applications, for critical requirements, it may not be possible for a person to afford any break. Just we have seen, because as I am taking this, I am delivering this session, and in between there is a disconnection. So what happens? We see that, okay, so many people are stranded, they are just waiting. But what about a system? What about an industrial control system? And suppose it is not able to get the information which it is supposed to get, it may end up in havoc. So that's why edge computing concept has come, which allows the analysis of data where it is. So this minimizes the latency time, and critical requirements are met without depending on network or external resources. And let us also not forget that if we are talking of critical data, cybersecurity itself becomes a big issue, because as you all understand that data at rest, it is much easy to secure than the data during transit. So if your critical data is moving from your internal system to the external world, there is always a chance of a cyber breach or data loss. So this brings us to our next important component of Industry 4.0, that is cyber security. So even in POWERGRID, we have gone in 2012, we set up our National Transmission Asset Management Center at Manesar, from where we are able to control almost 260 substations. That is, all these substations earlier had manpower 24/7 on that particular location, and any operational requirement they will have to meet, they have to operate, they have to switch a circuit out, or they have to switch in a reactor. So such activities they were doing on all 260 locations. So with the implementation of NT-AMC, we were able to control all these substations from one place, that is from Manesar. And but this has no doubt, it has improved a lot. It has saved a lot of manpower for POWERGRID. It's an excellent example of IoT. But it has also brought to the fore the criticality of cyber security, because if somebody is able to breach into that system, he can make the entire transmission grid to come at standstill. Actually, that has already happened in different countries. For example, I don't know whether you heard about Ukraine and a few more countries. But unfortunately, manufacturing companies have not always considered the importance of it unless actually the havoc hits them. The same connectivity of operational equipment in the factory or field that enables more efficient manufacturing, as I just now told, it also exposes new entry path for malicious attacks and malware. When undergoing a digital transformation to Industrial 4.0, we need to consider the cyber security aspect. We need to consider how we are going to ensure that no no external threat, no external agent is able to penetrate to the operational control system and create havoc. Now, coming to the next component, that is digital twin. A digital twin is a virtual model designed to accurately reflect a physical object. So when I have to reflect a physical object accurately in a virtual world, so what I basically need, what I need is I need to create model which faithfully follows the actual physical system. It needs inputs. It needs inputs from all sorts of sensors so that the real-time data can come in. At the same time, I have to model the system so that the virtual model or the modeled system is able to behave exactly like the physical object. So the object being studied, for example, a wind turbine, is outfitted with so many sensors of different aspects of its physical performance, such as energy output, temperature, weather, and much more. This data is then relayed to a processing system and applied to the digital. Once informed with such data, the virtual model can be used to run simulations. You can study performance issue. You can generate possible improvements. Okay, how this can be, if I change this particular parameter, will I be able to improve the parameter? So all this basically, the ultimate goal is to generate valuable insights which can improve the original physical object. Can I improve the design of the original physical object? Can I improve the working of the physical object? So with these concepts of Industry 4.0, basically comes the concept of a smart factory. So a smart factory is a digitalized manufacturing facility that uses connected devices, machinery, and production systems to continuously collect and share data. This data is then used to inform decisions to improve processes as well as address any issues that may arise. The smart manufacturing practices used by a smart factory are enabled by a variety of technologies which we already discussed. That is, for example, AI, analytics, big data analytics, cloud computing, IIoT. So these are the various technologies that could be used, and it's a concept basically to use to describe the application of different combinations of modern technologies. This is a great opportunity to improve the efficiency and flexibility by connecting different processes, information streams, and stakeholders, including the suppliers basically. So even we could get the data how the supplier is going to supply. Suppose there is a breakdown in the supplier's place. So we come to know, okay, my supply chain is going to be affected. So it's not about automation of one organization or one plant. It's about automation and integration of all the connected stakeholders and systems. So just I would like to discuss a small few this one here. That is, you with industry 4.0, you can, as I already told, you can take preventive actions. You can attend a component before it fails. You can, in fact, take preventive supply action. That is, for example, you can manage the logistics. You can, for example, let us say there is a printing system and your system detects the printing is low, and it is also able to understand the printing material is not available in the store. So it's able to place the order directly to the supplier. So this kind of functionality, predictive maintenance, when we have already seen, then we can even remote resource management, that is possible in a smart factory. And of course, managing the information in a centralized manner. So for example, all these substations keeping their, as I was discussing about power grid, that all these substations keeping their, managing their stores separately through their own software, and with the implementation of ERP sort of solution where we are able to get this data centrally and see in a centralized manner, okay, what is the status of my inventory across the organization, where what are the components which are being consumed more. Even one can go one step beyond that, okay, what kind of what may be causing for this particular component to be getting consumed more. Is it that failure rate is more, or a particular process is consuming more of that, causing the more wear and tear of that component, or maybe due to some environment factor, that particular component in a particular region only it is basically getting deteriorated fast. So such kind of centralized analysis is possible once we are able to gather the data on one place. So that's what we have seen, that with industry 4.0, innumerable and unimaginable improvements and efficiency and efficacy improvements can be brought in. So many new possibilities are there to explore, but not without a risk that is caused by the, I will use the word here, blind automation, as well as the cybersecurity sort of thing, risk. As just an example I was giving you about the grid. Now consider a connected car and some malicious actor is trying to take control and is successful in taking control of the driverless automatic car. Now what will it lead to? So while industry 4.0, it no doubt has improved our efficiencies and it has really changed the way we work and we produce the things, but it has also brought its own issues, what we are going to see now in the next slide. So that is about what are the issues what we are facing with industry 4.0. So basically it is lacking these main three features, which of the late we have basically, as our DP also was telling in the inaugural address, that these are the basically features which we are missing in with industry 4.0 sort of thing. We are missing the regenerative features of basically, so that we can embrace the circular economy and restorative feedback loops we don't have. We are just going on a linear way, and that is a very, very crucial drawback with the current system. Then coming to the social dimension, we are missing the attention which is required to be given to the well-being of workers, the need for social inclusion and adoption of technologies that do not substitute the humans. It basically complement the human capabilities as far as possible, of course. Not for the 3Ds what we discussed, the dull, the dirty, and the destructive or damaging work, but for value addition. And the last is about environmental dimension, which has become so critical, and human beings, though talking about it since long, have off late, we have basically woken up and we are thinking that, okay, we have to somehow reduce our carbon footprint and we have to become at least we have to become carbon neutral, latest by 2050 and by 2030 if possible. So what is Industry 5.0? So basically it's a paradigm shift. It is basically repurposing the industry for making it so as basically we have the Industry 5.0 is basically nothing but we are trying to repurpose the technology. Whatever we were doing is not replacing 4.0. It is rather complementing 4.0. It is rather giving a new direction to the technology. It recognize basically, as we can see that whatever we talk about any aspect of environmental harm or social this one, so we will find that industry has a very, very major role to play in that. For example, I give a very good example that, okay, we are talking of single-use plastic. But what about the other plastic which we are using in the wrap? For example, if I purchase a Maggie, I am getting it in some wrap, or even I go to market and purchase some, let us say, a packet of, let us say, rice. So even that is coming in some plastic, this one's which has a plastic packet, which has an environmental aspect. Or for that matter, even about the energy consumption. So whatever energy consumption, conservation we are doing at domestic places, certainly it is required. It is certainly we have, we all humans as a, it's our responsibility. But what about the industry? If you see, better effect can be had if it was the industry which turned towards greener options and greener initiatives. So that is the thing which we want, which is about Industry 5, that it recognizes the power of industry to achieve societal goal. The societal goal today is about ESG, what we are all aware. It goes beyond jobs and growth, and it basically is to provide prosperity by making productions respect the boundaries of our planet and placing well-being of the industry worker at the center of production process. As I told already, it basically is a complement of Industry 4.0. It's a vision of industry that aims beyond efficiency and productivity as the sole goal, because that is basically a linear way of thinking, and it basically gives a new direction to the industry, which is to help society in achieving the environment and social goals. It is sustainable, human-centric, and resilient industry model. Now, an interesting term which is coined by Japan Cabinet Office is Society 5.0. It attempts to balance economic development with resolution of societal and environmental problems. It addressing large social challenges based on the integration of physical and virtual spaces. So basically, to apply technology to achieve social goals. Society 5.0 is a society which utilizes advanced IT technologies like IoT, robots, artificial intelligence, augmented reality, and it is used actively in everyday life, industry, healthcare, other spheres of activities, not primarily for economic advantages alone, but for the benefit and convenience of society at large, as well as for each citizen. It's basically talks about the way we saw industrial revolution. That's here we are seeing as society stages. 1.0, it is hunting and gathering. 2.0, it is agriculture. 3.0, it is industrial revolutions, and in 4.0, it is about information, and now 5.0 is about the sustainability. So another term which we come across when we talk about Industry 5.0 is circular economy. It's a model of production and consumption which involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing materials and products as long as possible. So because you see, whatever modern thinking is about use and throw. So that is really posing a tremendous burden on our planet. So the circular economy is basically exactly to address that issue by the way of using these techniques, that is sharing, leasing, reusing, repairing. We have totally forgotten repairing. Once upon a time, for everything we used to go for repairing, but today we simply throw and bring a new one. So of late, societies basically waking up to that concept and going back to the basic of recycling and reusing. And the goals are the elimination of waste and pollution, then circulation of product and materials in order to keep them productively in use in the economy for as long as possible. So that probably a phone. And again, when I talk about technology, it brings a conflicting requirement. Probably, for example, if you take your smartphone, I think each and every one of us may be replacing in hardly 2 or 3 years. But let us say, suppose somebody decides to use it for longer duration. So what happens? Even if he is able to manage it, cyber security, because with the new systems, it is mandatory that you go on upgrading your, if not hardware, at least software to make it safe, because new and new threats are coming, new and new vulnerabilities are detected. So at the end of the day, even suppose you want to use the phone for longer duration, not only phone, even your laptop or your tablet or any other device. So basically you are forced on the name of obsolescence to throw it. So that's a basically design flaw which needs to be addressed and which will be very much required if we aim towards circular economy. We want to use the things for longer. So that's just a pictorial way that the present paradigm is use the natural resources, make some product from them, use for some time and throw that. while the circular economy tends to use those equipment for as long as possible by refurbishing and repairing. So again, the key facts about Industry 5.0 is aimed at supporting, not superseding humans. It's about finding the optimum balance of efficiency and productivity. So the benefits, you get cost optimization, you get greener solution, and of course, personalization of service and creative solutions. Coming to the components, the design component of Industry 5.0, you have to have human-centric approach. You have to build in the resilience and sustainability. There has to be a collaboration of humans and machines. We will see a term coined called cobots, that is collaboration of humans and robots. Then boost of customer experience and customization. One size fits all approach is no more acceptable. Now coming to the enabling technologies, as I was saying, collaborative of robots which work along with human workers and assist them and enhance their capabilities. Virtual reality and augmented reality for industrial testing, training of people, as well as inclusiveness, making the people who are challenged in some way to include them also in the process. Then advanced working instruments and safety equipment for enhancing human capabilities with robotic tools and data connectivity. Automatic recognition of human speech and gestures, augmenting cognitive abilities of human workers with AI and other innovative tech, then tracking devices to monitor health and mental state of human workers. I think this is becoming very critical for nowadays. Then digital twins for simulations. So this is some of the things which technologies, and we have already seen the components. So basically, to summarize, I will say that Industry 5.0 is not something which is totally different from 4.0. Is just basically giving a direction and complementing Industry 4.0 so that our human society can achieve our ESG goals and become sustainable and ensure that our planet continues to live forever. That's it. Thank you.
Mr. Mukund Sharab Hejib sir is not only a personal friend of mine, but he is one who explained to me what is information and communication technology when I was preparing my PhD thesis, and when it was rejected by the assessment committee, I was in soup. I again turned back to him, and then he helped me out, and I could get a PhD also. What I have learned from him and what participants were giving me the feedback, that this is one delivery which is not only informative, but it is also taking care of the time. The way it was started, the way it reached the peak, the way it provided the seamless metamorphosis of Industry 4.0 to Industry 5.0 is marvelous. On behalf of the participants from US, UK, Thailand, and of course India, which is having representatives from Insolvency Board of Government of India, Damodar Valley Corporation, Power Finance Corporation, and some research scholars from Sunrise University, and some of them are from my former employer in Lingayas Vidyapith, and participants who are there, beginning with additional director to whatnot. All of them are so happy on their behalf, on behalf of the World University, and on my personal behalf. I convey my heartfelt thanks to him, because whenever I am in trouble, he is there as the troubleshooter friend. Yesterday, when I sent a message to him, he was in flight, and the message could not reach him. The moment he landed, he informed, "Hey, relax, I am back, I have landed, don't worry about tomorrow." And I was really relaxed, and I could have good night's sleep. Sir, thank you so much. Have a great day ahead. See you soon in person as well.
Thank you, sir. Thank you
Namaskar.
for giving me this opportunity. Thank you.
Welcome, sir.